Okay, what I'm going to primarily talk about today is that Central Asian Archaeological Landscape Project. It's a 5-year project funded by Arcadia, a charitable fund of Elizabeth Rorsling and Peter Baldwin. And we're in about 3.5 years in now to the 5 years. And so it's about building digital heritage inventories across Central Asia. Forward. Okay. Why are you stuck? There we go. Okay. The study area is the 5 Central Asian republics, the ex-Soviet ones, so Turkmenistan, Uzbekistan, Tajikistan, Kazakhstan, Kyrgyzstan, and also the Xinjiang Autonomous Uyghur region of Western China. So a pretty vast area, really, and we're working with numerous partners. The aim of the project was initially to preserve archaeological archives and records through high quality digitization. It was also to use satellite imagery to improve the information about the location of sites and their extent, as well as discovering new sites. It was about undertaking fieldwork to document digitally those landscapes and ground truth the satellite work. It was combining all of these into a digital geospatial system to provide a platform for local heritage management and conservation specialists to protect their own heritage. To do that, it was also about building capacity in digital documentation, both in the archive and in the field. It's also looking at developing case studies to highlight the threats and the challenges that are facing archaeological resources in Central Asia. And very importantly, disseminating as much of this data as is possible via open access georeference databases of archaeological sites, monuments, and landscapes, and linking those to the archival data. As I say, the project has a lot of partners. So we, at the moment, have around about 65 staff employed locally across Central Asia. These are people working in existing institutions who are working on archive scanning, on digitization, on the remote sensing material. We also have some key partners, particularly the International Institute for Central Asian Studies, which is based in Samarkand, the ICOMOS International Conservation Center in Xi'an, and various other partners across the region. The challenges that Central Asian archaeology faces and why digital inventories are so important, as I hope we will explore during the course of this seminar, is, like many parts of the world, it's facing a whole variety of changes in agricultural practice, urban expansion, rural depopulation, the impact of COVID-19 during the course of the project and that's impact on things like heritage tourism, and perhaps most significantly, the climate crisis across the whole of the region. It's very much affected by the so-called third pole, the Himalayan Pamir ice caps, and the drainage systems that run from that. So south, the Indus and the Ganges, but north, the rivers that feed the Tarim Basin, the Aman Darya, the Sir Darya. And on the right of this image is the Atakul River from Tajikistan. It used to flow all year round. Now it only flows in the spring. That's having a massive impact upon lives, on communities, on the agricultural approaches to the region, desertification, new irrigation systems, all of which massively impact the people, all of which massively impact the heritage. So the data that we've been collecting looks at archival material. Across those Soviet states, ex-Soviet states, there's a system called the monument passports. Monument passports detail individual monuments, as one might expect, and chart them and what happens to them over time. Xinjiang has a similar sort of structure with a national and regional monument record. But there are also many, many archaeological records scattered across Central Asia and beyond. In the Soviet era, for example, each country, each republic had its own archaeological archives, but there was also a centralized archive in Tashkent, which reported to the Institute of Material Culture in St. Petersburg. And individual archaeologists, funnily enough, as in many places, kept their own archives, kept their own material, not least under their bed. So there's been a scattering of a huge amount of knowledge and work that's been undertaken over the past century, really, across the region. Very inaccessible, very disparate, and much of it quite fragile. So those monument passports, compiled initially in Russian, now taken forward in their own languages. So for example, the Turkmen one there on the right-hand side. Some of them have been computerized a little bit. Most have perhaps a version that's typewritten. A lot are still handwritten records. So quite a challenging issue to digitize. And indeed, the records across the whole region are very varied. Photographs, glass plate negatives, large-scale plans, paintings. And on the left-hand side, one of my favorites from Kyrgyzstan, where paper was in short supply. So it's old exercise books with seeming very pertinent at the moment, a Soviet army rolling across the margins of the paper, but that's simply used as a backdrop to stick photographs and hand-write labels on. So the digitization of this very fragile resource is complex. We adapted the British Library's Endangered Archives Programme work with their help to create the archive metadata. So everything that is scanned into the digital archive has a variety of information about its nature, its scope, its physical existence, and location, compiled in the language of the people who are doing the work. So perhaps in Russian, perhaps in Kyrgyz, perhaps in Tajik, etc. The remote sensing data, looking at the available material, of which there's a lot spanning across Central Asia, both looked at new sites. So for example, the image on the left here, finding small-scale way stations in the Karakum Desert in Turkmenistan, but also on the right-hand side, this is Amul, one of the important cities at the crossing of the Oxus River, the modern-day Amandarya, again in Turkmenistan, but documenting scale, change, boundaries, often not recorded in the monument passport. We've developed a QGIS, so open source software, geopackage to store the remote sensing and archival data. Work undertaken by Dr. Marco Nebbia here at UCL in designing this. So we've evolved the system with the help of people like Dave MacLeod, who was one of the pioneers of the English Heritage Aerial Photographic Survey, to look at how we document linear features, individual sites, clusters, irrigation systems, field systems, individual monuments. On the right-hand side, you can see that there's a series of tabs for the different types of data that we have, basic data about the site, the type of anomaly we're seeing, what imagery we're seeing it on, how it's interpreted, details about its size, understanding of its condition based on the satellite image and risk, and then metadata about the recording. And this has allowed us to document a vast range of sites across the region, some known previously, hopefully better located now, some unknown before. So building up patterns of data, linking that data into the photographic material, into the archival data. So here, material that's coming from the Tajik National Museum, being linked back to the location of the site. So complex interactions. We've also been looking at historic satellite imagery to look at what we can, particularly over the last 50 years or so, of how the landscape has changed and been impacted over that period. So, for example, look at the Amudarya River that borders Turkmenistan and Uzbekistan, looking at how that river system has changed. The red, how it was in 1971, the light blue, how it is in 2019. So a wide range of material available. We can look at specific issues and specific sites. So here's a corona image taken in 1971, not fantastic resolution, but smack in the middle of that image, you can see a small caravanserai or fort on a promontory. And that's what it looks like in 2019. So it's hanging in there. It still exists, but for how much longer in that changing river system pattern is another issue. We look at some of those threats we were looking at early on. So, for example, urban encroachment. This is a group of kurgans outside of Almaty in Kazakhstan. So the red area is where we're going to zoom into. Here's an image from 2014. And if you look at the brown field in the middle, you can see a whole series of circular anomalies, which are burial mounds, basically a huge range of burial mounds across that field. Here it is by 2018, and the urban encroachment has started to come. A road's been put through the middle. There's been some building, then there's more building expanding across it, and yet more building. And by May 2020, most of the southern half of this burial ground has actually been largely destroyed in that process. We're also looking at collecting other sorts of digital data. So along with that satellite imagery, we're doing a lot of work with unmanned aerial vehicles to produce high resolution, rapid documentation of landscapes, particularly better elevation models, for example. In certain circumstances, we're using laser scanning, differential GPS, we've used LiDAR in some places to build very detailed digital records of specific monuments, be they under threat or because they're actually in the process of being conserved and changed. At the moment, that database has around about 60,000 records in terms of remote sensing and monument records across the region, and about 13,500 archival records. And that's growing all the time. At the moment, we've got around about 11 terabytes of archival data to work with. As I said, Marco developed a QGIS geo package to handle the data and its complexity. And we chose QGIS for the reason that it is open source software and that we would be able to roll it out to our partners across Central Asia. We were very conscious as a university. We had ArcGIS, fabulous, great resource, wonderful analytical tools. But in reality, there was no way we were ever going to be able to afford to purchase that for every single partner across Central Asia, that they long-term would be able to sustain that and continue to pay the licensing fees. So QGIS gave us the opportunity to build something very similar, but something in an open source software that we could support, that we could train them, that they could grow with and develop as QGIS grows and develops in the future. It's also extremely important that we could handle multilingual resources. So the data's going in to the system in the language in which it was generated. So it may be in English, it may be in Russian, it may be in Chinese, but it may be in Kyrgyz or Kazakh or Turkmen, etc. And it was very important that people could be able to analyze that data. We're looking at various approaches to automating those processes. But one important thing we did was to develop a multilingual thesaurus of archaeological terms, which allows one to search for caravanserai, for example, in English, and find all of the caravanserais, whatever language they were input in. A very complex ID system had to be developed for different types of data that we're recording: heritage, people, activities, historical events, places, archives, remote sensing, to be able to control and manage the input of data and to be able to link that data together. All of this comes together in what we're calling regional archaeological maps, which are digital resources, building an understanding of landscapes. And these are the ones that we're currently working on. So they don't just deal with the digital data that's come from our archives and remote sensing. They also collect digital information about the landscape, historic maps, land use, and model digitally issues about condition and risk, which I'll show some examples of. So this is one, the pilot one that we originally started with, which is the Katlan region in Tajikistan. And here, overlaying onto the satellite imagery, we have digital elevation models. We have land cover dealing with crops, urban areas, river networks. We have the historic corona imagery to look at change over time. We've digitized the Soviet maps, largely from the 1950s and 60s, and geo-rectified those, and then combining that with our data from about monuments, archives, remote sensing, and the people and institutions who are working across this landscape. The objective is to be able to use this data to help our local partners, to provide them with the platform to engage people, to work with local communities, to work with planning authorities, to work with the political process in protecting and managing heritage. We can't fight to keep heritage. We can't argue about its significance or its impact if we don't know where it is and what is happening to it. So we've undertaken a spatial risk assessment. This work's already been published by Marco, Federica, and our local partner, Bobomula, from the National Museum in Tajikistan in 2021, and the reference is there at the bottom. So I won't go into too much detail, but what it's doing is it's taking that data and using computational approaches to try and assess risk, to try and look at replicable models, and to see how those change. So for example, looking at where sites have been identified, looking at those issues about how they're changing over time, looking at about the spread of agriculture and the change of irrigation systems, looking at the changing river systems. Here, a particularly noticeable example of the change in the river between 1971 and 2019. And you can see the sites digitized from a 2013 satellite image, which are now disappeared under the course of the river by 2018. Marco and the colleagues worked on this spatial risk assessment. So they looked at comparative indices: topographic wetness, slope, distance from towns, distance from major rivers, to explore the potential of sites to be under threat or to be damaged. And again, I've referred to the article of the sort of detail of how this is actually structured, but a multivariate regression analysis to look at these different factors and then model those. For example, areas where human activity or riverine erosion is particularly likely to cause damage. areas, as I say, of river flow, looking at the difference between our problems about whether it's our visibility of the data as opposed to the reality. So lowlands, for example, are not confirmed at being at higher risk. It's perhaps because they've either already been destroyed or we can't see the landscapes as well. So that's working towards informing how our field surveys would operate. Another example, we undertook a risk assessment of the Labat region along Turkmenistan, along the Amun Darya River. Similar sort of approach, looking at densities of sites, looking at different types of threats, looking at where the pressure points were most likely to be and where the high risk areas were. One factor in sharing this data and in using this data for both research, for heritage management, for engaging with communities, is the pressure to create open data resources, but also the issues about who owns the data and the copyright of the data. We set out very firmly at the outset to say that the copyright, the ownership, the intellectual property of this resides with the archiver, with the generator of that data. So each archive has a relationship to the people who've deposited data there, or the institutions that have deposited data, and they have their own attitudes about how much they are prepared to share of that data. Some institutions have been incredibly open and are happy for all of the data to be open access. Some want a more restricted approach where we can share the metadata so that you at least know that the site exists, you know where it is, you know what information is available in the archive, you know the depth and quality of that data, but you perhaps still have to apply to that archive to access that material. So some very complex issues around access. We started at the outset with the idea of using the Arches system, which is a heritage inventory system developed by the Getty Conservation Institute and the World Monument Fund. It grew out of a project in Jordan, Mega Jordan, and was then turned into this open access, open source, online geospatial database. And for us, it offers two great potentials. It's in its outward facing and open access levels, there's a great deal of control about how you can manage and present the data. And it also initially was very good as a multilingual platform. It had been developed in Jordan for being in English and Arabic, and so could deal with complex scripts. Rather sadly, it kind of lost some of that functionality in some of the later versions, but is getting it back. So Arches 7, which is due out in the summer, is going to have a lot more of that multilingual aspect to it. And indeed, we've been contributing aspects to that process. So what it offered us was the opportunity to present an online version of the database. So the data managed, handled, analyzed through the QGIS and its rollout with its analytical capabilities to our partners, but an online system which would allow people to search data, to explore the data sets. It has a variety of controls about access. So for example, as you see in the top right, it says, welcome Tim, as I've logged into the system. And you can have very complex logins. So there's everything from unregistered users who can still access quite a lot of the data, right the way through to someone who could actually have editorial control over aspects of the data, and virtually everything in between. One of the things that was very interesting about it was the ability to control access to each individual field. And therefore, one very important issue was for unregistered users, we would only allow a zoom in, which would give you broad distribution maps, but not allow you to actually directly locate the site, the specifics of the site. And part of that is associated with issues to do with land ownership, and partly, and very much to do with issues about looting. So the data that is accessible for those dots on that map, if you're an unregistered user, is most of the information, but not anything that provides locational data, not the coordinates, etc., etc. If you're a registered user, then you can have different sorts of access levels. So you can zoom right into the system here and look at individual details of the monuments. The data is held in a series of what Arches uses as resource models. So there's one for activity, which is excavations, surveys, etc. Actors are people, institutions. Archive, pretty self-explanatory. Heritage resource grouping allows you to group together a number of sites, for example, different buildings within a town. The heritage resource model is the individual record. Events models of historical events, remote sensing model, information resource models about links to other material. And we've kind of replicated the Arches structure in the QGIS design. And there's just an example of the heritage resource model and the different interactions of fields, etc. within that. One of the things that, as I said, that was particularly important at the outset was creating a multilingual thesaurus. So it's possible to look for various terms in whatever language you want to and find them in others. Arches also has a very powerful relational basis. So for example, if you want to search for caravanserais, you can just search for the term caravanserais and it in all its other languages, or you could also have associated terms like Han or Funduk. And we can see the same thing, religious complexes, different types of structures, different languages to search for them in. And one can have much more complex research search patterns as one would expect. The open data aspect of our digital repository is particularly crucial. We use the UCL research data storage to actually bring all the data together and guarantee its long-term stability and maintenance. We use the UCL research data repository to actually share that data with the world. So again, this depends on whether the institution is happy. In this case, one here from Uzbekistan, perfectly happy. So if you follow that DOI link to the repository, you can get all of the documents, all of the photographs, etc., etc. Another example, this is the Great Kizkala at Merv. If one follows the link from Arches, one can get to the repository, which has a page about the Kizkala monuments. Very importantly, that each page has its own DOI, so we can link that into the database and also link it to all of the other resource elements. From that DOI, there are references which take you to material which is available through UCL or somewhere else. So for example, by following that, one can go to a published open access article about semi-fortified palatial complexes in the Great Kizkala. One can go to Sketchfab and actually look at the three-dimensional models of the monument. You can go to YouTube where there's a fly-through video of it. And really, as it were, in conclusion, what's most important about this project from our point of view? And in part, it's those objectives in the beginning that we said about preserving these archives, making sure we don't lose them, making sure that they're accessible, that they're migrated, that they're there for future generations, making them accessible as possible, both to encourage wider use and research, but very much so as a platform for decision making. from distribution maps, from better understandings of landscapes, or on the right-hand side, very complex AutoCAD models of a condition of a specific monument in Bukhara. This access to this information and the ability and capacity to know how to use it is crucial for our Central Asian partners, be they ministries of culture, be they museums, be they archaeological institutions, be they regional authorities. It's vital that we can use this data, that they can use this data, that they find benefit from using the data in this digital format to be able to inform strategic thinking about the future of heritage resources across the region. So we very much focused on thinking about landscapes, not just sites. There's been a tendency, and the Monument Passport system was very good, but there's a tendency to focus on the outstanding monuments. But in reality, what makes the heritage so special is that complexity, that interaction between place and landscape and people. If we want to engage local communities in the significance of their heritage, we need to be bothered about not just those iconic sites. So for example, at the top, the Yusukol district in the Chui Valley in Tajikistan, and the red ring show burial mounds within this gradually growing and expanding settlement. Now you can see that a lot of those are still actually preserved, whether by accident, whether by design. But understanding that landscape gives an opportunity for our local Tajik partners to work with the local community to raise awareness about the quality and importance of the survival in that landscape, and to think about how this can be sustained against the needs of the community to grow, to develop, to change their agriculture, etc. The one at the bottom is a set of preserved field systems and irrigation canals around a fortified settlement. And this is about 9 kilometers north of Serak in a semi-arid area of Turkmenistan. Now, the fortress is well known, well documented, and preserved as an ancient monument, but actually nobody really had ever explored that landscape around it. And the significance of the fortress changes completely as one sees it in that landscape context, and indeed the quality of that survival around the landscape. So again, working with local archaeological institutions, in this case, the Ministry of Culture's archaeological parks, to think about how to manage that landscape, but also to be aware of that landscape against a changing pattern of rural and urban development across the region. We were able in Horizon to look at using our data to help with a European Bank road development scheme. So there was a scheme to develop new roads for connection across the region. We were able to use the archaeological data collected both through the archival and remote sensing to look at the impact of suggested routes, to look at alternative routes, to look at the impact on the historic landscape of Hiva. And again, the ability to do this because the data is collated, because it's digital, because it's accessible, because we, from sitting in London, could talk to and communicate with our colleagues in Uzbekistan and discuss the significance of the material, really changes our ability to help, but also their ability to articulate the complexity of the landscapes through which this road passes. And I'd finish with the International Archaeological Conference that took place in Nukus in 2021. And this was a kind of a relatively high level, semi-diplomatic meeting of agencies across the region, including UNESCO. And it came together under the issues about archaeology and tourism, but it actually ended up with a call for a Central Asian declaration on the principles of archaeological heritage management. And what I particularly like about this is it called for a unified electronic state register of archaeological sites. To quote Article 9, in order to effectively organise the documentation, registration and protection of objects of archaeological heritage, the relevant authorities shall maintain a unified electronic state register. And as an integral part of that register, there should be an electronic archaeological map, including a register of lost archaeological sites. So in some senses, I would like to think that this movement, which has already been adopted by Uzbekistan, is probably going to be adopted fairly soon by Tajikistan, Kyrgyzstan, and Kazakhstan. I hope by Turkmenistan when the borders open up again after the pandemic, and we can discuss it in more detail. But what it does is it gives a regional mandate in some ways for the sustainable outcomes of the CAL project. I believe that it's because the agencies across all of those countries have seen the value of digitizing their data, of managing that digital heritage, of applying that digital heritage for both outreach and research, but also for heritage management and an understanding of how the impacts of the 21st century can be managed and how digital inventories can help that process. So I'm hoping that this is the outcome of what we're doing, and we hope that we'll go on beyond the year and a half that's left of the project and be able to further embed the training and capacity building across the region. So I'd like to thank you for your attention. And as I said, there's a whole range of institutional partners, but also many project team members. And really, we've got 5 or 6 people working in UCL in London, but really it's the 60-odd people who are working in those institutions across Central Asia who are really making the difference, and I hope the difference to the sustainability of what we're attempting to do. Thank you.